All right, so today we are going to continue our 8.3 notes and talk about rhombus and square. A rhombus is a parallelogram with all four sides congruent, and there's a picture there. A rhombus has all the properties of a parallelogram, plus that its sides are congruent, plus these two additional diagonal properties that we're going to go over below. So the diagonals of a rhombus, there's two things we need to know. Theorem 8.15 says if a parallelogram is a rhombus, then its diagonals are perpendicular. So the example here is if parallelogram ABCD is a rhombus, then AC, that's one of the diagonals, is perpendicular to the other diagonal, BD. And then we can also mark it up on here as perpendicular to each other. Okay, 8.16 says that if a parallelogram is a rhombus, okay, so same start, then each diagonal bisects a pair of opposite angles. Okay, so that's one that's a little bit that we haven't seen much of before. So let's look at this example here. And the example is if parallelogram NPQR is a rhombus, okay, then these diagonals across are actually bisecting the angles they go through. So that means angle 1 is congruent to angle 2. You see how this one right here is cut in half? Okay. Angle 3 is congruent to angle 4. So this one is cut in half. And since they were the same across from each other were congruent in the first place, we can say that actually all four of those angles are congruent. Angle 5 is congruent to angle 6. This is a different measure, so it gets a double arc. And angle 7 is congruent to angle 8. And that's actually going to get a double arc as well because N and Q were originally the same angle measure. Okay, and then if we zoom out for just a second, I know this is a lot of information, but actually that first theorem can actually be conversely said as well. So that one goes with 8.17, and then 8.16 actually has a converse as well. So we're going to talk about that. So maybe make a little note there that 8.17 is actually the converse of, this should be an 8.16. So basically it just switches the if and then statements. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So in this case, the example is going to be if JL is perpendicular to KM, then parallelogram JKLM is a rhombus. So if you first know that the diagonals are perpendicular to each other, then you can say, okay, well, the whole thing is a rhombus. Okay, and then conversely to the 8.16, you can say if one diagonal of the parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So we're going to our example here. Here's our drawing. We're going to say if angle 1 is congruent to angle 2 right here, and angle 3 is congruent to angle 4 right here, or, okay, you only need to know one of these two things, or angle 5 is congruent to angle 6 and angle 7 is congruent to angle 8. So, or this side is congruent to each other. So the diagonal bisected that. Then parallelogram WXYZ is a rhombus. Okay, so we learned 4 new theorems there, but 2 of them were just converses of the other ones. Okay, so let's go ahead and so now we are going to look at example 1 using the theorems we just wrote down. The diagonals of a rhombus FGHJ intersect at K. Use the given information to find each measure or value. So we're going to start with A. Part A says if measure of angle FJH equals 82, so that's actually that entire angle FJH, that entire big angle, which I marked in blue. If that's 82, then we need to find measure of KHJ, which is that little red angle with a question mark, okay? So we need to write this in statement reason form. So basically we can say that it's given that this is a rhombus, which is really helpful. So we know that actually this diagonal GJ actually cuts that 82 in half. So I actually know that angle KJH equals, well, first I'm going to do a line above it. Angle FJH is 82 because that's given. Okay, sorry, this is my statement and my reason. Okay, and then the next line is KJH, which is that smaller angle is going to be 41 degrees. So that's right here is 41. Okay, and then we're going to write out that if a parallelogram is a rhombus, diagonal is angle, sorry, we'll shorten it, is angle bisector, which we just learned. Okay, so that cuts it in half, that's 41. And actually, this is a rhombus, so we also know that this angle here, HKJ, is 90 degrees because the 2 diagonals are perpendicular to each other. So I'm also going to say that angle HKJ equals, equals 90 degrees. And that's because diagonals of a rhombus are perpendicular. Okay. So actually now we have 41, we have 90 right here, and then the one we're looking for is in the same triangle, this little bitty triangle here of JKH. So we can actually add those 3 angles together up to 180. So we can say we can say 41 plus 90 plus measure of angle KHJ, which is what we're looking for, add up to 180. So we can say angles in a triangle add up to 180. And then we can just solve this and we can get measure of angle KHJ equals 49 degrees. And we subtracted 41 and 90 to both sides. All right, so we're using a lot of different theorems there. Okay, B, the same question, or the same example, I redrew the rhombus right there. If GH is x plus 9, so that's this length here, and JH is 5x minus 2, we're going to find x. Okay, well, there's something that we know that's really important, that it's given to us that this is a rhombus, which is actually great. We don't have to prove that it's a rhombus first. We already know that it's a rhombus. So we actually know that GH is parallel to JH. I'm sorry, not parallel, congruent. And that's because all sides of a rhombus are congruent. Oh, actually, I am going to write the shorthand of congruent so that we can remember how to do it. And then that actually wasn't a theorem. That's the definition of a rhombus. Okay, so then we can say that GH actually just equals JH, which is definition of congruence. And then we can just start solving. So x plus 9 equals 5x minus 2. (11) equals 4x. So I did two things there. You have to do the math on the side if you want to, but we added 2 to both sides and subtracted x to both sides. So then our final answer is x equals 2.75, and that's dividing by 4. All right, so that's the answer right there. All right, we have more theorems here, okay? So if a pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So actually, all we need to know is that if two sides are congruent that are next to each other, because that's what consecutive means. I'm going to write a little note here. Then actually, they're all congruent and it's a rhombus. Okay, so our example is if AB is congruent to BC, then the whole thing, parallelogram ABCD, is a rhombus. And actually we can mark up the rest of the parallelogram with the single marking. I'm sorry, the rest of the rhombus. Okay, and now we're moving on to a couple of square definitions and theorems. So a square is a parallelogram with 4 congruent sides, but also 4 right angles. So we're adding a property here. So look at that next sentence. A parallelogram that is both a rectangle. Okay, let me write in there what we're thinking about. Okay, a rectangle means that it has 4 right angles, which actually is right here, our property that we just mentioned up there. And if a parallelogram is both a rectangle and a rhombus, which means it has 4 congruent sides, and that's this property up here that we just mentioned, then the parallelogram is also a what? Okay, so if it's both a rectangle and a rhombus, then actually it fulfills the needs of a square. Okay, so if it's both a rectangle and a rhombus, then it's also a square. Okay, so hopefully this diagram here helps us to understand that a little bit. So we have a big circle called parallelograms. And so we can have some random parallelograms out here, one over here. Okay, one down here. Remember, a parallelogram just needs to have opposite sides parallel to each other. That's all it needs to be a parallelogram. And then, let me go find this drawing. And then there's certain types of parallelograms. On one side, there are rectangles, okay? If it has 90-degree angles, it goes into this category, but it's still a parallelogram, okay? It just needs 90-degree angles. All right, and then over here, we have rhombuses, which are actually rhombi when it's plural. So in this side, so over here, I'm gonna write 4 right angles. Okay, and then on this side, all we need is 4 congruent sides. So over here it can still be slanted, but all 4 sides need to be, congruent to each other. Okay, so maybe these lengths are all the same length, okay? And then when those two combine, when you have both 4 right angles and 4 congruent sides, then it can fall into this category inside them of a square, okay? So that looks like 4 congruent sides and 4 right angles. So hopefully this diagram helps you out a little bit there to understand what quadrilaterals can be. Okay, and then there's one theorem for a square, which is if a quadrilateral is both a rectangle and a rhombus, which we basically just said above, then it is also a square. Okay, let's put this into action with the last example. All right, the last example is example number 4. Determine whether JKLM parallelogram with vertices given right there in those points is a rhombus, a rectangle, or a square. List all that apply. Explain. Okay? Remember, if it's a square, then it's all 3, because a square is a rhombus and a rectangle combined. Okay? Or it could just be a rhombus or just a rectangle. So the first thing I'm going to do is I'm going to graph this. So go ahead and look at the biggest number I need is 9. The smallest number I need is -7. So it's really important to be intentional with your graph drawings because it really helps with accuracy on your estimations and on what your drawing looks like. And I'm going to plot J, which is -7, -2, -7, -2. K, which is 0, 4. L, which is 9. Oh, it goes to +9. 8, 9. Oh, no. Sorry, 8. Okay, 9, +2, right here. And 2, -4. Okay, right here. All right, so this one was K, L, M. And I can already see that it probably isn't going to have right angles, but I cannot just eyeball it. I have to prove that, okay? So the other thing I want to talk about is diagonal theorems really quick to try and figure this out. So we could do this many different ways. We could measure the side lengths, and then we could take, is this side perpendicular over here and stuff like that. But we are going to work with diagonals so that we can use our new theorems, okay? So I'm going to draw the diagonal here. All right, and then I just need to take some notes on the side over here about diagonals. So I know that for a rhombus, the diagonals, the only thing we know about the diagonals, well, they are bisectors of the angles, but we don't want to write that down. That's not important. Diagonals are perpendicular, okay? For a rectangle, all that we know about the diagonals is that the diagonals are congruent. I'm going to write are congruent. And then for a square, it's both. Okay, so it's that the diagonals are perpendicular and the diagonals are congruent. Okay, so it's a combination of rectangle and rhombus. Remember, whenever it's both, it becomes a square. Okay, so we're going to test some of this information. So let's start with if the diagonals are congruent to each other by doing the distance formula. Okay, so we're going to find, remember distance formula, I'm going to write it one time right here just as a reminder, is the square root of x2 minus x1 squared, and then the difference between the y's squared. Okay, so we're going to do the first diagonal, which is JL, okay, or sorry, KM. I'm going to do KM first. So KM is going to be, so you go use the points above that you already wrote down. You can get the square root of 68, which if you pull out, the only thing you can pull out is a 4, is a 2 sets of 2 if you want to break it down into 2, 2, and 17, okay, which actually only these two can be pulled out, so it becomes a 2 square root of 17. Okay, we're going to do the same thing with JL. Nine minus negative 7, 2 minus negative 2. We're going to get the square root of 272. And you could also just find the, you could just plug that into your calculator and get the decimal version of this. It doesn't really matter. All you see is that they're not the same length, the two diagonals. So we're going to write 2 square root of 17 does not equal 4 square root of 17. So let's go look back at our choices here. So diagonals are not congruent. So that eliminates a square, because see how it says diagonals are congruent? That eliminates a square, and that eliminates a rectangle. So all we need now is to prove that it's a rhombus, okay? And remember our theorem up here, if diagonals, let me go find it, right here, 8.17, if diagonals of parallelogram are perpendicular, then the parallelogram is a rhombus. So all we need is to show that those two diagonals are perpendicular to each other to prove that it's a rhombus. Okay, so I'm going to go ahead and find the slope of the first diagonal, which is KM. And that, remember slope, I'm going to make a little note over here, slope is y2 minus y1 over x2 minus x1. Okay, so we're going to do our slope, which is negative 4 minus 4 over 2 minus 0, which is going to give us negative 4. And then we need the slope of the other one, of JL. It needs to be the opposite reciprocal. Okay, so we'll see if that works. All right, so we have negative 4 and positive 1/4. So the slopes are negative reciprocals, which means they are perpendicular. Okay, so we can say that this is a rhombus since the diagonals are perpendicular, but nothing else.